In this video, we'll be exploring the data access tool on Predictive Science's new MHDweb 2.0. This tutorial is part 11 of a 12-part series that is designed to guide users through this website's data visualization tools. If you've not done so already, I recommend reviewing part 1 of this series, which covers in greater detail this website's architecture, general visualization workflow, and the mass run database. This tool in particular benefits from the context provided in part 1 as it explores directly our mass run database. The data access page itself is accessible from any of the tools that we've covered so far in this tutorial series. You can find it in the Tools widget on the right-hand side of your screen, right here at the bottom. You can also find it in this drop-down menu up here under Data Access. So as you can see, this page resembles the simulation selector that's available from each tool. The ability to filter runs, query notable events, and view the run metadata are identical, albeit they're formatted somewhat differently here. The key difference between the two interfaces is this menu at the bottom here, titled Selected Simulation. This widget is similar to the simulation widget that you can find on the right-hand side of each tool. And what these options here provide you, and this is sort of reminiscent of Plot 1D and Plot 2D, is that it'll allow you to specify which domain you're interested in pulling data files from and what state from within the selected run you wish to consider. This time of interest field is simply used to determine which state from the available states you would like to fetch. So in this case, since I'm examining a steady state run, there's only a single state to choose from. But let's say I wanted to examine a time-dependent run where you've got many states to choose from. I'll choose the Eclipse 2024 Live. And now you'll see this drop-down is populated with a lot more states. So you can either select the state directly here, or you can use this time of interest field to determine which state from that drop-down menu you are selecting. Now, once a state has been selected, the available data files for that particular run, domain, and state are shown to the right here. You can select from these buttons one or more variable data files to download. So by selecting the radial component of the magnetic field or temperature. Alternatively, if you want to select all of them, just click this first button here, or you can clear that selection by clicking it again. Also, as you might have noticed, if you want to see a more verbose description of what the particular data file is, just simply hover over this button. So JR corresponds to current density, the radial component of that. CHmap refers to the coronal hole map, or this is heat refers to local coronal heating rate. Now, as I mentioned in part 2 and 3 of this tutorial series, when I was covering Plot 1D and Plot 2D, certain domains contain data files that are unique to that domain. So if I was to select, I'll clear these filters and select the Thermo 2 run that I was examining earlier, and select the state here, you'll see that you have a wide range of data files. Now if I select the heliospheric domain, some of those data files are not available for the heliosphere where they might have been available for the corona. Namely the EM and EP, which refer to wave energy density, both anti-parallel and parallel to the field. So let's say I wanted to fetch the vector components of the magnetic field. I would select these 3 data files here. And once those selections have been made, you can go ahead and click Download Data. Note this may take some time, but once the data has been successfully fetched, you will receive a zipped file containing the query data. The resultant files are saved in HDF4 or HDF5 format, with the one exception being the output log file. And to read in and explore these files, we've developed an open source Python package called PSIpy that can be used to load and visualize PSI's mass model runs. This package offers a wide range of Pythonic visualization data products and is available through PSI's GitHub page, which I will link in the video description below. So, with that being said, that concludes this somewhat brief overview of the data access tool on Predictive Science's MHDweb 2.0. For further information regarding the mass run database, once again, please refer to part 1 in this series, which goes over that in greater detail. The next and final video in this series will be a sort of informal demonstration of what a typical workflow looks like when using MHDweb, covering the full scope of this website in practical terms. If you have any questions, comments, or concerns, please leave a comment below. And once again, thanks for watching.